I want to talk about combining like terms. But to talk about combining like terms, there are some things you need to know first. First and foremost, what are terms? So terms are combinations of numbers and variables that are separated by addition and subtraction in either an expression or in an equation. For instance, 3x plus 3 minus 4p. This has three different terms. One of them is 3x, the next one is 3, and the last one is negative 4p or 4p, depending on how you want to list it. Those are the three terms of this expression. So those are what we call terms. Like terms are terms that have the exact same variable to the exact same power. So for instance, 3x and 2x are like. However, 3x is not like with 3x squared because of the exponent. Because of this, these are not like. Okay. Similarly, 3x is not like with 3y. Okay. 3x is not like with 3xy. Even though they both share an x, because 3xy also has the y, they are not like either. So it has to have only the exact same variable or variables, and they have to be to the same power. With that in mind, 3xy would be like with 3 or with 2xy. Okay? Notice that they have the exact same variables to the exact same powers. So what do I mean by combining like terms? Well, combining like terms happens when we're dealing with an expression or equation and we want to simplify. Let's look at this example again. 3x, and then we're going to say plus 2x plus 4. Okay. If I want to simplify this expression, I can simplify it because I've got these two like terms right here, and I can combine them. So I can rewrite this as 3x plus 2x, which is 5x plus 4. Combining 3x and 2x because, again, they're like terms. It can also work for equations. So let's solve an equation. 5 equals 5m minus 23 plus 2m. 5m and 2m can be combined because they're like terms, so that makes 7m. So now we have 5 equals 7m minus 23. Now we're going to solve this just like we were solving our other multi-step equations by adding 23 to both sides using inverse operations. Now we have 28 equals 7m, divide by 7, divide by 7, m equals 4. So combining like terms can be a step in our solving of multi-step equations. Equations might also have fractions in them, and we haven't talked a lot about fraction math. Remember, it's something I'm sort of expecting you to know by the time you're in this course. If you need a refresher, there is a supplemental video on how to do math with fractions, but let's look at it as it pertains to equations. So here we have 3/4 x minus 1/3 x, and that equals 10. Well, the math you do with fractions doesn't change. So we're going to use the information we just talked about, identifying these as like terms because they are both x terms, right? So they're like terms, and we want to combine them. But we can't combine them because they don't have a common denominator. So we're going to need to find a common denominator. Hopefully you've noticed right away they need to be renamed as twelfths. So we're going to say some number of twelfths x minus some other number of twelfths x is going to be equal to 10. 3/4 becomes, well, we multiplied by 3 to get to 12, so we have to multiply 3 by 3 too, so that's 9/12. We multiplied 3 by 4 to get to 12, so we multiply 1 by 4, and that becomes 4/12. Now we have 9/12 minus 4/12 x. The x just stays with them as we do the subtraction, and we have 5/12 x equals 10. We've done this math before, so we have to find the reciprocal of 5/12, which is 12/5, and we want to multiply both sides by 12/5. That cancels out to 1, leaving us with only x on this side. 10 divided by 5 is 2, times 12 is 24. So x equals 24.